systems means there's more than one. We're used to solving like an equation, right? Solve for x or solve for y or solve for whatever letter it is. This chapter, we're going to have more than one equation that needs to be solved. Now, if you have more than one equation that needs to be solved, isn't it possible you could have more than one answer? Yeah. So what we're actually going to be doing this chapter is solving two equations that have two variables. So you're going to have like an x answer and a y answer. Nick, did I see that you just joined? Yeah, okay. Nick, there's if you want a notes packet, they're in the main office if someone wants to come pick one up for you, okay? All right, so we're just gonna do a quick review first. Now, in order for something to, if you solve a problem, right, that's its solution, it works, right? It works if you plug it back in. So what we're going to practice right now is just something we did at the beginning of the year, and that's seeing if something is a solution to an equation. Corey and Jaden, you guys ready? You have a pencil, Jaden? You can grab one. All right, so remember from the beginning of the year, determine if x equals -1 is a solution to each equation. So we have the value x equals -1. And then don't we have equations down here? What letter does do these equations all have in them? X. Okay, so these are equations with an x. And then aren't I telling you in the directions that x equals -1? So where should I put that -1? We're going to replace the x with it. Exactly. We're going to substitute or plug -1 in. So if you see an x in your problem, we are going to plug that -1 in there. Now a little hint for when we plug things in, and I'm going to really start stressing this chapter. When you plug a number into an equation, does anyone know what you should always put it in? Put it inside of something? Parentheses. You should put it inside of parentheses. Because sometimes, like, can't your negatives get jumbled, or maybe your signs get jumbled, right? Do you always need them? No. But do they ever hurt? No. So we're going to plug in. So this is a little strategy that you're going to see I start to do a lot this chapter. Anywhere you see an X, I think we did this when we did our T-charts. Instead of writing an X, put an open set of parentheses, okay? And then we're going to plug in the number we need. So we're going to do open parentheses -8 equals -9. So instead of X, I put open parentheses because we're replacing the X with what number? -1. So then I'm going to plug in my -1. And then we're going to go through and simplify. Now, that -1, isn't it on the front of your equation? Nothing's being multiplied by it. There's no extra signs. Is it really like doing anything? No, it's just there to kind of separate it. So in this situation, the parentheses didn't really affect anything, but they don't hurt either. So we can just go through and simplify. What is -1 minus 8? You might want a calculator if you don't know. That would be 8 minus 1. It'd be -9. So on the left, we have -9 equals, well, on the right, wasn't there already a -9? Does -9 equal -9? So did this work? Yes. So I'm going to put a little check to be like, yeah, it worked. We got -9 on both sides. And we were supposed to determine if it was a solution. So I'm going to say, yes, it was a solution. It ended up working. So we're just plugging it in. So let's look at number 2. Where do you see x's in number 2? Yeah, I see 1 before the 4, so I'm going to put an open set of parentheses plus 4. And then there's 1 hanging on to this 3, so I'm going to put a 3 and then an open set of parentheses. Now, what am I plugging in instead of x? -1. So I'm going to plug my -1 in. And now let's simplify. Over here, we're just adding, so the parentheses don't really do much. What's -1 plus 4? You plug it into your calculator if you need to. -1 plus 4. 3. 3 equals. Now over here, these parentheses are actually helpful in this situation. Because was there a sign, like an addition, subtraction, multiplication, or division sign between the 3 and the x? No. But when I have these parentheses here, what does that kind of tell you need to do? Multiply. If those parentheses weren't there, wouldn't you maybe have accidentally subtracted? Yeah, probably. So what's 3 times -1? -3. Huh. Well, what looks funny about that? Yeah, one's a positive, one's a negative. Does 3 equal -3? No. So what I'm actually going to do is put a little slash through my equal sign. That means does not equals. And we're going to say not a solution. Or just no is fine as well. But not a solution. All right, and then we got one more. We have 2x minus 1 equals 3. How should I rewrite this? Like with my blank parentheses. What should I write down? Yeah, 2 blank parentheses minus 1 equals 3. And in that blank parentheses, we're putting what number? -1. Now, in this situation, this is another place where these parentheses help. Because it's going to help us with our order of operations here. Doesn't this tell us we need to multiply first and then subtract? Again, if you didn't have those parentheses there, you might have accidentally subtracted twice. So order of operations, we're going to multiply first. What's 2 times -1? -2. So, and then drop down your -1 and your equals 3. What's 2 minus 1? Or I'm sorry, what's -2 minus 1? -3. And ladies and gentlemen, does -3 equal +3? No. So does this one work? No. We would again say not a solution. Okay, that's good practice too for some stuff we're going to have to do later in the week or next week because today's Thursday. Okay. We good, Jaden and Corey? Following along? All right, so a system of linear equations. That is a set of 2 or more linear equations, like y equals mx plus b. This is an example of what that could look like. One's normally stacked on top of the other like this. So if you have something like x plus y equals 7, that's technically a linear equation. It's just not in y equals mx plus b form. It's in standard form instead. And then 2x minus 3y equals -11, that's also a linear equation. There's 2 of them. And you'll notice, don't they have an x and a y? And we're going to solve for both. That's what we're going to be doing. Okay. A solution of a system of linear equations is an ordered pair that is a solution of both equations in the system. Now, when I say an ordered pair, do you guys know what an ordered pair is? An alternate word for ordered pair is a coordinate point. Your solutions are going to be points like x, comma, y, like that. I would write that down. They're going to be points like that. Okay. So what we're going to do next is tell whether the ordered pair is a solution for the system. So we've done it with 1. We saw if one number was a solution, but now we have 2 variables, so we need to see if both are solutions. Now, in order For this to work, it has to work for both equations and both numbers. So here you have a point, and remember in a coordinate point, this is your x, right? This is your y. And then we have two equations. We have the equation x plus y equals 7, and we have the equation 2x minus 3y equals negative 11. What I'm going to do is put 2 in wherever I see an x, and I'm going to put 5 in wherever I see a y. Okay, and we can still use our parentheses. Now, if it works, that's great, but then you have to keep going and check the second equation. If the first one you check doesn't work, then does it really matter if it works for the other one? No, if it doesn't work in one, it has to work for both, okay? So let's try this out. I'm going to try to color code this. We're first going to try out x plus y equals 7. So that's this top one here. Okay. So now in place of the x, what number am I going to put? 2. In place of the y, what number am I going to put? 5 equals 7. And then let's test, let's simplify. What's 2 plus 5? 7. Does 7 equal 7? Yes. So that one works. That's good, but if that one works, do we still need to check the other one? Definitely. It might work in one, but then not work in the other. We don't want to be tricked. Okay, so let's check the other one. We got 2x minus 3y equals negative 11. Now this one, isn't there a lot going on in this problem? I would use some parentheses here. So let's rewrite this one with, instead of our letters, we're going to put our blank parentheses so we can make sure things get plugged in correctly. So I'm going to put 2 blank parentheses minus 3 blank parentheses equals negative 11. Okay, so 2 blank parentheses, we got to plug our x in there. What was our x value? 2. Okay. Minus 3 times our y value. What was our y value? 5. And then this is helpful because don't the parentheses tell us we need to multiply? Yeah. Okay, so let's do our order of operations. Multiplication first. What's 2 times 2? 4. Then I'm going to drop down my minus sign. And I'm also going to simplify this other part. What's 3 times 5? 15. So I'm going to have 4 minus 15 equals negative 11. Okay. What's 4 minus 15? Very good. Negative 11. And does negative 11 equal negative 11? It certainly does. So, did this work for both? Yeah, so is it a solution? Absolutely. So we're going to put yes, because it worked for both. Good. All right, let's check number 2. And then I'm going to probably have you guys check one on your own. All right. Let's look at number 2. We have the coordinate point, negative 2, 0. So negative 2 is your x, 0 is your y. And then we're going to plug these in here. So my first one is this equation, y equals negative 2x minus 4. Do you want to rewrite this one with some parentheses? I probably would, right? It can't hurt. So instead of y, we're going to have parentheses equals negative 2 parentheses minus 4. That just tells us where we got to plug things in. Corey, you writing this down? Okay, so let's plug this in. Y is on the left here. What are we going to plug in for y? 0. So 0 equals negative 2 times x. What was our x? Negative 2. Then minus 4. Okay. Now, don't we just have a 0 on the left? Just a 0 in parentheses. Is there really anything we can do with that? No. So I'm just going to leave that as 0 and bring it down. And then on the right, I need to do some simplifying. There's some stuff happening. What should I simplify first? Is it 2 minus 2? What does it mean when there's parentheses there? You have to multiply. So what's negative 2 times negative 2? 4, good. So we'll have 4 minus 4. And then simplify again. What's 4 minus 4? 0. Does 0 equal 0? Why, yes, it does. That's supposed to be a check mark. It's just really ugly. Okay, so that one worked. We still got to check the other one out, though, don't we? Okay. So for our other one, we have the equation y equals x plus 4. So we're going to have blank equals blank plus 4. All right, what's our y value that we're going to plug in? 0. So you're going to have 0 equals, and then x plus 4. What was our x? Negative 2. Do we need to do anything with that 0 on the left? No, it's just by itself. Bring it down. Equals. And then you just have negative 2 plus 4, right? Anything we need to worry about multiplying? No, it's just negative 2 plus 4. There's nothing else going on there. What is negative 2 plus 4? 2. Ladies and gentlemen, does 0 equal 2? No. So this worked for one of them, but it didn't work for the other one. So what do you think we would say? This one, no. If it doesn't work for one, then it's just a no. This one is not a solution. Good. All right, I want you guys to try out number 4. Try out 4. Now, something I want you guys to be careful about. If you look at number 4, see how there's an x in front of that negative? I'm sorry, there's a negative in front of that x in your second equation. You can't just ignore that. That negative has to come with you, okay? So try it out. How do you plug this in? Okay, so why? So you did 4 equals and then what? Okay, so yeah, 4 equals 3, parentheses 1, and then plus 1. And then how did you simplify after that? Good, which is? Okay, so you, yeah, 3 plus 1, then which is 4. So 4 equals 4, that side worked. Now we're on the other side. Hayden, what would you do over there? Yeah. Yeah, yeah, and this is the thing I was warning you guys about. That negative in front of the x, you can't ignore it. Bring it with you. It goes in front of your parentheses, okay? So negative and then your parentheses. Okay, so negative 1 plus 5, and then what'd you do from there, Hayden? Yeah, I would bring down the 4 as well. And then if you just have a negative outside of the parentheses like that, doesn't that just make this a negative 1? Yeah, all it does is it makes it a negative 1. And negative 1 plus 5 is? Yeah, 4. So did it work for both? Yeah, so this one is a yes, or you could say solution. Either way. Okay. All right, so we are going to take a 4-minute break today. 4 minutes because we have a shortened class. You're lucky I'm even you've been on a break all class. All right, so 9 o'clock. 9 o'clock, we're going to do the back. So people at home at 9 o'clock, we're going to do the back. Sounds like a personal problem. I don't have to give you anything. I know, right?
I don't know everything now. You come check it.
I wouldn't say that that's everything.
Yes, no, yes, no, no, no.
Yeah, there was a lot more to it than that.
Hey, I did it correctly. So.
Or you just wrote down the word I wrote.
mean?
Mm,
I can do number 3 right now.
okay. Doesn't mean I'm not going to give you a hard time that you just have your head down. I've been talking to him the whole time too. Hey, now. It's not your job.
That's what my history.
Yeah?
He said he had a teacher. Or no, he doesn't do that. He said he had a teacher that did that. And then one year, the teacher went up, he had a ruler. He slapped on the desk, he missed, and hit him right in the wrist.
Ooh,
And he had to stop doing that.
that does not sound
And it
pleasant.
left like a big welt, like all the way across his wrist.
Oh, I don't want that.
My teacher just yells, like really loud. Just goes, sneaks up to him, and he yells. And then he makes him stay after class to talk.
Yes.
This is the whole unit, right?
No.
You just do this the whole time. Pretty simple.
It'll get more challenging. Oh, yeah.
Never gets easier. I'm here. Jake, I must have COVID. My hair's falling out.
Uh-oh. Oh, yeah, Jake, didn't you say that your hair fell out?
Yeah.
My hair always falls out, though, so I wouldn't even know. I shed like a wild animal. Oh, always. Oh, mine always has,
Your dog.
basically.
Should look it up.
Between me and my 2 dogs, our house like gets like tumbleweeds in the corners. We have to vacuum it like twice a week. I don't know what you're talking about. I don't know what you're talking about, Jake. I live a very healthy lifestyle.
No, you don't.
I
3 hours of sleep is not healthy.
know.
10-hour days and 3 hours of sleep is.
And sometimes more than with online, with all the online learning, I'm working more than 10 hours. I would say at least 12.
Not okay.
No, I know. Thanks, guys. Thanks for looking out for my health.
Alex is bad.
What do you mean? He's been bad.
He's back from the dead.
From the dead? He was here the other, oh, I guess he missed on Thursday. Well, he was here the other day. Yeah. Were you? Oh, yeah. I forgot you were here Tuesday.
She says, welcome back.
Yeah, I totally forgot. Well, I totally forgot you were here Tuesday. I can't remember now. Yeah, I don't remember, to be totally honest with you. All right, let's keep going. Well, that'll be their problem. Okay, so, well, that sucks for them. They'll miss the blanks that I'm filling in. All right, so next thing that we're doing, people at home, we are back from our break. So make sure we're back in front of our computers. Solving a system of linear equations by graphing. So this is going to be our first strategy. We're going to learn 3 strategies this chapter: graphing, substitution, and elimination. We start with graphing, so make sure you have a straight edge or something. So we have 3 steps. When you solve a linear or a system of equations by graphing, again, a system means you have 2 equations. So if you graph 2 equations, there are a few different things that could happen. We're actually going to look at these little graphs here first. These are the 3 different things that could happen if you graph 2 lines. First of all, couldn't your lines cross? Yeah. Couldn't your lines be parallel and never intersect? Yes. Couldn't your lines actually be the same equation, just written 2 different ways? Yeah, and that's when they almost end up being one line. They lie on top of each other. So these are our three scenarios. When you solve a system of equations, what you're technically doing is looking and seeing where your two graphs cross. That is their solution. It's basically the point that they have in common. They have that same point. So our three steps here. Step one is to graph each equation in the x, y coordinate plane. So you're going to graph each equation on the coordinate plane first. Yes, Bailey. I haven't fixed it yet, no. Okay, estimate the line, or not, sorry, not the line. Estimate the point of intersection is what that's going to say. Intersect the point of intersection. Sorry. That means basically the point where they cross, okay? I'm sorry? The point of intersection, like an intersection at a road, right? Like, yeah, like a stop sign. Then you can check the point by plugging it in for x and y in each linear equation. We don't normally do that, but sometimes if you're worried about the answer you're getting, it's a good idea. Okay, so again, these are the three scenarios that can happen. Your lines might cross. If they cross, then you end up with an answer. Your answer is actually the point where these two lines cross. So like if you looked at this set of lines right here, I'll zoom in a bunch. See they cross at this point? This point is actually the point 4, 2. That would be their solution. Go ahead, Alex. I would use the electric one. It's a lot faster. Huh? Okay. So don't these two lines cross at the point 4, 2? So that's their solution. Okay. So that's one scenario. That's when the lines cross. Okay, so if the lines cross or intersect, you guys didn't seem to like the word intersect, so I wrote cross. If the lines cross, then there is one solution. It's a point. Sometimes we'll have no solution. That means the lines did not cross, right? The lines actually end up being parallel. They never intersect, so there's no solution. They don't cross. You could have done it before. And then infinitely many solutions, that actually means that the lines are the same. There's sometimes more than one way to write the same thing. And if the lines are the same, if you graph one, won't the other one technically lay right on top of it? So it would touch at every single point on it. That's why it's infinitely many. You might have. All right, so we're just really all we're gonna do now is graph and see what happens. If they cross, we're gonna figure out what point they cross at. That's our answer. If they don't cross, we'll say no solution, okay? So now this is the reason why we had to review graphing yesterday. Hopefully you did that. If not, then hopefully you remember it. So we reviewed graphing yesterday because we're graphing today. So when you graph, please stop. When you graph a line in slope-intercept form, remember, put a dot where your intercept is and then count out your slope. Your slope is your rise over your run. You can put as many points as you want down because you can count out your slope as many times as you want. I would say the more points you have, the more accurate your line will be, okay? So I'm going to color code this. We're going to start off with our first line here. That's y equals negative 2x plus 5. So remember, you need to identify your slope and your y-intercept. I would start with your Okay, so your y-intercept is 5. So what that means is on the y-axis, we're going to put a dot at what number? 5. So put a dot at 5 on your y-axis. Remember, that's the vertical one. So put a dot right there. Then what number is your slope? -2. So if your slope is negative, from that point, should you count up or down? Down. Down how many? 2. And then do you guys remember how many you go over when it's a whole number? 1. Because it's like -2/1, right? That means the same thing. So from that point, from our intersection, we're going to count down 2. So 1, 2, and then right 1. What if you couldn't count down and to the right? What's a good alternative? You can do the opposite. You could go up and to the left. Now you can do this as many times as you want. You can put as many points as you want. Something you guys are going to notice is the more points you have, the easier it's going to see where the two lines cross. So down 2, right 1. I'm going to put a few. And I'm actually, it's important that I have nice straight lines here. So I'm going to actually use my line tool. So that way you guys can actually see where this needs to go. Okay, so it would look like that. There's my line. Oh, yeah. All right, now let's graph the other one. We got y = 4x - 1. Jake, what's your y-intercept on this problem? -1. So we're going to put a dot at -1. And then Lynn, what's our slope? 4. Somebody tell me, how do I count out a slope of 4? Up 4/1. Why up instead of down? Because it's a positive number, right? So up 4, 1, 2, 3, 4/1. What do you guys notice when I plot that point? Didn't it just end up on top of another point? That's actually a good thing. You want that. Because isn't that now going to be the point where our two lines cross? So I'm going to do this one more time. Up 1, 2, 3, 4/1. Just so, oh, I put that in the wrong spot. Just so I have a nice line to draw. So up 1, 2, 3, 4/1. All right, and here is my other line. And can you guys see where they cross? Yeah, what point did they cross at? Yeah, right here at 1, 3. Here, let me do that in a darker color. Right here. Yep, that's their solution at 1, 3. So we're going to put the point 1, 3, and that's our answer. And that's all you got to do. Graph them, see where they cross. That one probably took us longer than the rest will because I was trying to remind you guys how to graph. People at home, any questions yet? Hopefully we're there. Nope. Okay, cool. All right, let's go over to number 2. We're just gonna roll through a few of these and then I'm gonna have you guys try one out on your own. All right, so number 2, we have y = x - 2 first. Let's do that one first. So okay. So I'm going to start calling on people to tell me what my y-intercept is, what my slope is, and how to count out my slope. So get ready. So y = x - 2. Jaden, what's my y-intercept for that line? -2. So put a dot at -2. Now this one, what would your slope be? 1. If you can't physically see a number there, it's the number 1. Up 1/1. Very good. Up 1/1. What if you didn't want to go up 1/1? You could just do the opposite, down 1/1. And again, you can do that as many times as you want. I would say do at least 3 though. Yeah, I mean, the more you have, the more accurate it's going to be. Okay, so that's what your line should look like. All right, there it is. Y equals negative x plus 4. Alex, what do you think your y-intercept is for that one? Okay. Oh, sorry, you're drawing your line. 4, good. So put a dot at 4. If you have a negative in front of an x, what do you think your slope is then? -1. Hayden, how would you count that out? Down 1/1 this time. So down 1/1. And couldn't I keep counting down 1/1 until it actually hits the other line? Would that make it easy to see where my points cross? Yeah, down 1/1, down 1/1. Again, you can do that as many times as you want. And I did a bunch of them. And then I can nice and clearly see where they're going to cross. And then I can just draw. Oops, didn't mean to do that. Heck. I know. There we go. And now I can just draw my line. Yeah, this is probably the easiest of the 3 strategies. Yeah, the homework is literally just trying out, I think, 4 graphs or something. All right, good. Let's, we're gonna skip around a little bit because there's a certain one I want us to do together and then a certain one I want you guys to do on your own. So we are gonna do number 4 together. And then I'm gonna have you guys try out number 3, okay? Why, oh yeah, just count, yeah, they should be easy to count out actually. But I want us to look at 4 for a particular reason, which we'll see in a second. Okay, so number 4. So our first line here is -x plus 2. Corey, what's my y-intercept for that equation? 2. Good. Aaron, what do you think my slope is? Yes, I did. If there's a negative in front of that x, what does that mean? Uh-oh, who can help Aaron out?
I can help him.
Jaden, help him out. What's the, well, don't hit it with my ruler. What's the slope? -1. So Aaron, when there's a negative in front of your x, it would just be a -1 because there's like no number that you can see. So when you can't see the number, it's 1. And then since there's a negative, it's -1. Does that make sense? Yes, okay. So Aaron, then how do you think you would count out a slope of -1? Down 1 and then right 1 actually, because you want to go in the negative direction only once. So down 1, right 1, and you guys can do that as many times as you want. Please don't do that. Or go up 1, left 1 if you prefer. Okay, either way, because that's how they snap. Is when people do that at the table. All right, then draw your line. Again, you can plot as many as you want. Are you guys kind of seeing that the more points you plot, the easier it is to see where they cross? Yeah, and it's up to you. I would just say at least 3. Okay, now on the other one, we got y equals -x minus 3. Jesse, what's my y-intercept? You there, Jesse? Okay, Jesse's not sure. Kaysen, do you know what your y-intercept would be? Dallas, what would our y-intercept be? You're not sure? Okay, so we have y equals -x minus 3. Which of these numbers do you think would be the y-intercept? -1 or -3? -3, yeah. Does that kind of make sense, Dallas? So it's that number on the back. So we're gonna put a dot at -3. And then Mason B, what's our slope and how would we count it out? Good, and so we would just go where? Yep, down and to the right. Good, down and to the right. And you guys can do that as many times as you want. You guys notice something that's happening here? They are not going to intersect. These lines are parallel. Yes, they are. Oh, except I didn't draw them very parallel, did I? Which one did I do wrong? I did something weird. I just think it's at a weird little angle here. Okay. So these lines are never going to intersect, so what do we say? Yeah, we would say no solution. No solution. You could, but I mean, that's technically not telling me how many answers there are, right? So no solution. All right. I want you guys to try out number 3. Try out number 3. For this one, remember, if you have a slope like a half, it's 1/2, right? So that's your rise over your run. So you go up 1/2. If you have a slope of -3/2, go down 3/2. So try that one out. Oh, we got y equals 1/2 x plus 3. Lynn, what's your y-intercept? 3. Put a dot at 3. And Bailey, how do you think you count out a slope of 1/2? How many would I go up and how many would I go over? Very good. Yes, you go up 1/2. Or if you needed to do the opposite, go down 1, left 2. So there's your first line. Good. And then Brooklyn, what's your y-intercept for the second equation? What kind of a 5? Negative. So put a dot at -5. And Annalise, what's your slope and how would you count it out? Yeah, down 3, right 2. Bailey, I would check your problem here. Down 3, right 2. Now, what else should you do? Would you only want to go down? I would count a few in the other way, right? So you can see where they cross. So I would also continue to count up 3, 1, 2, 3, and right 2 until you see where they cross, because it's going to make your life a lot easier when you're checking that. Okay? So then you can nicely see where they cross. So I would maybe count in both directions if you can. And then can someone tell me what point do these cross at? Yeah, these cross at -4, 1. It's this point right here. Oops. I'm sorry. What about, oh, I don't know what just happened. What about 29? Oh. So right here, that is -4, 1. Sorry, guys. All right, so your homework is in your packet. It's the 5-1 assignment. I would like for you guys to have it done for tomorrow so we can move on, because it shouldn't take you very long, right? It's pretty easy. If you need to come in and borrow a ruler during SRT, you're welcome to do that, okay? Everyone has SRT today, so you should get the chance to work on it. Let me know if you need help. Have a great day.